Welcome back everybody to Desktop Inventions. Now today we're going to find out how much money you can save by putting this silly little piece of foam onto your 3D printer. So let's go! So what's the point to put this foam on your 3D printed bed anyways? Well, let me tell you about that. A 3D printer needs a heated bed when it lays down the molten plastic filament so that it can stick to the bed properly. Otherwise, the print can come loose from the bed and you'll be left with a giant mess. So 3D printers are designed with a heated PCB as the bottom layer of the printing bed. And then on top of that is an aluminum plate for rigidity. And on top of that is your printing surface, which is usually a glass bed, or in some cases a magnetic sheet with a steel sheet on top of that. But no matter the construction, the principle is the same. You want that heated PCB to transfer heat upwards to the printing surface where your part is sitting on. But the problem is, if that heated PCB is open on the bottom side, it's also transferring heat outside to the environment, which is wasted energy and, more importantly, wasted money. But today we're going to test putting a layer of insulation on the bottom of the heated PCB so we can minimize our lost energy and our lost money. So now that we understand the theory behind it, I'm going to set up a test plan so we can figure out exactly how much power we're saving. So I'm going to be doing an identical print over and over again, but first I'll be using PLA with a 50 degrees Celsius bed, which is the stock setting that the printers usually come with. Then I'm going to do PLA with a 60 degrees Celsius bed, which I think is what most people set their settings to. And after that we're going to do ABS with a 80 degrees Celsius bed, and then one last print, ABS with a 100 degrees Celsius bed. And once all that's done, we're going to add the foam sheet to it and print all 4 test setups again and see how much money we saved. To measure the power consumption of the printer, I'm going to be using this power meter, which displays volts, amps, watts, as well as kilowatt hours, which is the important one to calculate the energy usage. As a further data point, I've installed 2 thermocouples underneath the bed, so we're going to track before and after the insulated sheet how warm it is getting underneath the bed. And we'll be reading that with this digital thermometer here. Now for the printing test. Since I have so many benchies already, I decided to print something that's not a benchy. So I designed a simple rock, paper, scissors cube that I thought would be a nice gift to give out to some friends. Then after that, I scaled the cube to be exactly a 1-hour print. So now I've got the first test part printed out and it looks okay, so I decided to use a brim on this print to give myself a higher chance of success with all these different print settings. Now with this print you can see the rock, paper, and scissors side of the cube, which I think is pretty cool. So I printed off the first couple rounds of prints with the stock printer set up. And now for the upgrade. Since you can buy these insulated foam bed sheets on Amazon for $8 or $10, that's pretty cool, but I thought I'd try something else. So I still have a bunch of foam from the box that my CR30 printer came with, so I decided to use some of that for free and see how it compares against the one I purchased online. So this upgrade is about as simple as it gets. We're going to remove these nuts off the 4 corners of the bed. Then we're going to take and flip over this bed here so we can see the bottom side of it. Now I'm going to clear this bracket and these silicone spacers out of the way. Now I'll go ahead and take my free foam sheet and cut it down to the right length. I was going to measure and mark some holes here, but then I found out I can just push the foam sheet onto the studs. That's much easier. So then I cut a few slots in each of these 4 corners so then I could slip that silicone spacer into the foam sheet there. With this all assembled like this, friction actually held things in place really well. Also, when I assembled it back on the printer, this bracket on the bottom also held things into place, so that foam was not falling down. Now time to spin the 4 nuts back on and let's get to some printing. At least you'd think it'd be that easy, right? Wrong. So it turns out I had some interference in the back on this stepper motor. Since this foam sheet was basically free, I just decided to mark up this area, and I was going to take a razor blade and hack this area out, even if it looked a little bit ugly. This foam was made from several layers of sheets glued together, so it's pretty easy to cut through that first layer and then cut and peel that first layer off. So now with that simple fix complete, let's get it reassembled and test it again. Just like anything, it's always faster and easier to reassemble the second time. Now with everything reassembled in place, it looks like we're clearing that back stepper motor just fine. Now I've got everything put back together and I've got a few more prints under my belt, so let's go look at the data. Oh yeah, scissors cuts paper. Here's a graph of the power consumption of the 3D printer over the course of a 1-hour print, and we can see right away there's an initial spike there. That's due to the bed heating up in the beginning. And then after that we can see the power drops down to a low point there. That's when the bed is already heated and then the nozzle goes into heating mode. After the nozzle and the bed are both preheated, the printer starts to print each layer, and during the first few layers the power consumption stays low. Then it steadily ramps up as the fans kick on and the hot end has to do more work by melting the plastic. Next we get into the steady printing stage where the power consumption stays pretty level, but there are small fluctuations as the bed is trying to maintain its temperature. So now let's look at our first graph of the printer with and without the insulation. So this one is at 50 degrees Celsius bed temperature printing PLA. And we can see the steady state power is just a little bit lower there with the insulation added. And while the lines on this graph are actually showing power, we can think of energy, or the part that we pay for, is actually the area underneath the lines on this graph. So the amount of energy we'd be saving, and therefore money, is represented by the shaded area in between the two lines on this graph. And now we can look at that same graph, but this time for 60 degree bed temperature printing PLA. And again, we can think of the energy saved as the shaded area between these two lines. Now looking at the graph with an 80 degree bed temperature, this time printing ABS, we can see there's a little bit larger gap between those two lines, which means more energy savings. And finally here we can see the graph for the 100 degree bed temperature. And what's different here is the steady state power consumption is actually higher than the peak power consumption in the beginning when we're heating up the bed. But when we added the insulation to the bed, the steady state power consumption was actually lower than the initial bed heating power consumption. Okay, so let's look at that data in a little bit different format. So in this graph we can see for each printing temperature how much energy we're saving over the time of that print. So first off, for the 50 degree bed temperature, we can see we saved about 6.5% energy. And for the 60 degree bed temperature, we saved about 9.2% energy. And really ramping up at the 80 degree bed temperature, we saved 12.5% energy. And finally at the 100 degree bed temperature, we saved over 13% energy, which is some pretty huge savings. Wow, pretty crazy to think of all that energy I'm saving on a piece of foam that I would have just otherwise thrown away. What's that? You're not here for the energy savings, you just want to know how much money we're going to save. Well, we'll get to that. But first, we're going to see how this professional piece of bed insulation foam that I bought online compares to the free piece of foam that we just installed on the printer. So let's go see that. Right away we can see this professional piece of foam is a little bit different. It's got this reflective layer on the outside, which is intended to reflect away outside heat instead of absorbing it. From this angle we can see this new piece of insulation is slightly thinner than the area I cut out on the original piece, so we should have no problem with the stepper motor there. Now I will say installing this piece was a little bit more tricky. I had to spend some more time to cut holes to fit those silicone spacers into, and the adhesive made it a little bit difficult in this process. And now I've got an ABS print done with the new bed, so let's go ahead and check out some results, see if it's any better. So here you can see the graph for the total energy consumption, and under this 100 degree test I added all three printing configurations, and we can see with the Pro we saved a little bit more energy than the regular insulation, but it was pretty much about the same. So now with all the energy data, I went ahead and calculated the cost savings you would actually get per hour of printing with this, and this is assuming 14 cents a kilowatt hour. And these numbers are really small. These are all less than a penny. Alright, let's zoom out a little bit. How about if we look at savings per 24-hour day of printing? Okay, this is a little bit better. At 50 degrees we'd save about 2 pennies a day, and at 100 degrees we'll save over 12 cents a day. But let's zoom out a little bit more. Okay, so 24/7 printing for an entire month, and if you add an insulated sheet to your bed, you'll save about 75 cents if your bed is 50 degrees Celsius, and at 100 degrees you'll save over $3.50. And while those aren't huge numbers, they probably start to add up if you had a print farm. And anyways, it's always nice to save a little bit of electricity here and there if you can. And just in case you're curious on the numbers, here is the full electricity cost for printing for a month before and after the installation. And if you're not sick of numbers and data yet, I've got a couple more for you. So we did save some time in warming up the printer. It was really negligible at 50 degrees Celsius, just 4 seconds, but when we're printing ABS, it was a little bit better at up to 30 seconds. And lastly, from the temperature measurements we took under the bed, saved a little bit, about 1 degree on the low end and 3 degrees on the upper end, so not too noteworthy. There we have it, folks. Now we know we can all save a little bit of money at home by adding the foam to the bottom of the 3D printing bed. And if you want my honest opinion, I'm a fan of the free stuff. So if you buy a new 3D printer, don't throw this foam away, put it on the bottom of your bed and save some money. Thanks everybody for watching, and I'll see you next time at Desktop Inventions.